So we're going to move into the word problems in this class. Calculus word problems, related rates questions. And they're all going to be about finding how a quantity is changing at a specific moment in time. And when we take the derivative with respect to time, we see the instantaneous change of that quantity with respect to time. Now, what quantities are we talking about? Well, we'll be talking about like real world things like areas, perimeters, circumferences, angles, distances, and all of these have formula. Now these first six, these formula you need to know. You need to have memorized. So if you forgot that the perimeter of a rectangle was twice your length plus twice your width, well, remember that. If you forgot that the area of a circle is pi r squared, you need to remember that. If you forgot the circumference of a circle is 2 pi r, you need to remember that. If you forgot that the diameter of a circle is equal to twice your radius, you need to remember that. If you forgot how to find the distance between 2 points using the Pythagorean theorem, you need to remember that. And if you forgot SOHCAHTOA, Chief SOHCAHTOA, you need to remember him. Like sine or cosine or tangent. Okay? Now that's all great and all, knowing these formula, but what we're going to be doing with these formula, that's what's going to be part of this lesson. That's going to be the difference between geometry and calculus. Is that we're not just going to look at the formula, we're going to be looking at the derivative of the formula with respect to time. I'm going to ddt all of these formula, and I need to be comfortable finding the derivative of all of these formula. Okay, some will have the product rule, like L times W. We'd have dL dt W plus dW dt times L. And we also have on the left dA dt. It's going to be very important to understand that these formula is a variable equals an expression, right? So I'm not just going to have the right side. I need the left side equals the right side. The derivative of P, dP dt, 2 dL dt, plus 2 dW dt. Area of a circle. Now, sometimes pi trips people up. They see pi and they're like, oh man, I don't know how to deal with that. Well, pi is just a number. If I had the area formula as 3r squared, you would tell me that the derivative of 3r squared was 6r dr dt, right? Well, just treat pi like 3. It's just a constant, no product rule involved. You just take that constant and multiply it by the derivative, pi times 2r dr dt. And that's equal to dA dt, the area of my circle. The circumference of a circle, dc dt equals, now it's just 2 pi r, r to the first power, like 2r, 2x, the derivative of 2x is 2, the derivative of 2 pi r would just be 2 pi, but we need dr dt. Okay, now these formula are really interesting if you think about them. You don't really have to think about them that much though. You just need to apply them. You need to be able to answer the questions asked of you. The dd dt is 2 dr dt. For distance, 2 capital D dt will be 2x dx dt plus 2y dy dt. These are all, fairly straightforward. And then, sine would be cosine theta d theta dt. We need a d theta dt. Theta is a variable. And then you use the quotient rule on the right side. Okay? So, these are supposed to be known to you. Look at that. Okay. These, most likely unknown, and that's okay. For situations when you're asked about the volume of, maybe not cube, you probably have to know this, but you'll be given these formula in the future. Volume of a sphere, 4/3 pi r cubed. Volume of a cylinder, pi r squared h. Volume of a cone, 1/3 pi r squared h. But again, we will be taking the derivative of these formula as well. Let's at least do 4/3 pi r cubed. Take the derivative of 4/3 pi r cubed. And maybe not volume of a cube, but let's do surface area of a cube. Of a sphere. Surface area of a sphere is 4 pi r squared. Four-thirds pi, just a constant, okay? This would be dv dt equals 4/3 pi times 3r squared dr dt, right? The derivative of r cubed is 3r squared. Now the 3 and this 3 can cancel, and you just get 4 pi r squared dr dt. Okay? Derivative of your surface area, you'd get 8 pi r dr dt. Okay? Now, these are unknown. These will be given to you. No need to memorize if you don't have them memorized. Okay, so that's the first thing. We need to be able to take derivatives of formulas. The other thing we need to do for these calculus word problems is we need to express certain things in the word problem using calculus notation. Okay? For example, if I am told that the radius of a circle is growing at 3 inches per second, I can say that the change in my radius at a given moment in time equals 3. dr dt equals 3. That would be kind of what that statement is telling us. If my radius is growing, the change in my radius at a specific moment in time is 3. Now the perimeter shrinking, well, if perimeter is p, you'd say dp dt, and since it's shrinking, the change in my perimeter is negative. You'd say this is -5. Area of my circle is increasing, dA dt. Horizontal distance. Typically, we'll talk about x's being horizontal distances. Okay. Now we're going to do some of these examples. The rest of the examples will be for your homework. I don't want you to have to write down all the questions, so I'm giving you this handout of the questions that we are going to do. The remainder are homework. You might want to use scrap paper to do the question the first time, and then, write down a nice, easy to follow answer on the worksheet. It's up to you. But let's start solving some of these easier related rates problems. Next class, we're going to do some harder ones. Okay? So we are told the volume of water in a container over time is given by the equation of 10h cubed times 4 minus h. This is the easiest type where you're given a formula where h is the height of the water. The water level rises at 2 feet per minute. At what rate is the volume increasing when the height of the water equals, let's say, 2? I'm not sure if this works out nicely in terms of the numerical answer, but at least we can do it. Okay? Now, to solve these simple related rates, and maybe in your notes you'll write a couple of key things down, is you need to write everything down, including what you're looking for, using calculus notation. We do not want to plug in values into our original equation if those values are changing. Okay, so we're going to pay special attention to fixed quantities or fixed relationships compared to changing quantities. The first couple you won't have to worry about it, but we'll get to a couple examples where these fixed quantities are important. Okay? So, first question. We got my volume formula. H is height of the water. Water level rises at 2 feet per minute. Okay? Well, that would be how my height is changing. This would be dH dt. And it'd be positive. The question is, at what rate is the volume increasing? That is, what is dV dt? When the height of the water is 2. Okay. We also were given the formula for volume. Well, now this is like a problem that we did last class where it's like, these are x's and y's, here's dx dt, find dy dt when x is, it's the same thing. We just took these words, we turned it into calculus notation. Well, now we're going to take the derivative of this formula, plug in our information, and solve for what we're trying to find. One important thing is that this h value, this is not fixed, this is changing. Since it's changing, do not plug it into your original formula. A lot of people like to say, oh, h is 2, plug in 2 here, but then they just get what the volume is. And that's great and all, like you can find what the volume is, but that's not the question. The question is, how is my volume changing at the specific moment when the height is 2? Okay? Now, so we're ready to take the derivative with respect to t. However, before I do that, just word of advice, go ahead and distribute the 10h cubed. Also, you will be able to use a calculator for your next quiz and for your test if you want to find your numerical answers a little quicker than doing things by hand. You can leave your thing in like calculator ready form, just solved with numbers in it. It's fine. Okay, but here's my volume equation. I want to find dv dt. Well, I take the derivative with respect to t of this, and I'll have dv dt on this left side. I then can plug in and solve. And if I have a calculator, I can use it to get this final answer. And let's get our answer and check it with a neighbor. Sure. Get this answer, check with a neighbor.
She's not in trouble.
Who's?
Sarah Davis.
Oh, Miss Davis. Wait, do we have a Davis? We have a Henry.
Sarah Henry, sorry.
Miss Henry.
Okay.
She's Twitter famous, I heard.
Not quite.
Not quite? Okay. All right.
Yeah.
What do we get? 320? Great. Well, that's better than the first time I did this question. Okay, so we got a dv dt when h was 3 of 0. And then it's like, well, how's the height rising but the volume not changing? And I said, I don't know. So this is good. Now let's talk about units. We're going to need units. Volumes are always in cubic units. Heights are always in units to the first power. Areas are always in units to the second power. So this would be in units cubed. Well, we're talking about feet and minutes, so this would be cubic feet per minute. Cubic units. Okay? Great. Piece of cake, right? Easy. Should be easy. Let's do the next one. A spherical hot air balloon is being inflated. If air is blown into the balloon at the rate of 2 cubic feet per second, how fast is the radius of the balloon changing when the radius is 3 feet? I want everybody to write down everything that they get from this question using calculus notation. And also, you will be given, for a question like this, that the volume of a sphere is 4/3 pi r cubed. Okay? Write everything else down, including what you're trying to find and what's given to you. Now, if air is blown into the balloon at a rate of 2 cubic feet per second, what is that? That is volume, right? It's in cubic units. Think about air being blown into the balloon. Well, that's changing like the entire shape of the balloon. That is dV dt. Okay, go. These are the easiest ones where you just take the derivative, you plug in everything, you're good. Check your answer with a neighbor. We need to be able to take the derivative correctly. This simplifies nicely.
You want it in terms of pi or?
Either? It's 2 over 36 pi, which is 1 over 18 pi. Which is some decimal. What's a decimal? 0.01768 or 0.0177. You can either truncate, which means just leave everything off after the third decimal place, or round to the third decimal place to be 0.018. Either answer would be acceptable. We round to 3 decimal places or truncate after 3 decimal places in this class. Now, what are our units? Right, radius is in units to the first power. Our units are feet. Our time is seconds. Not so bad, right? Not so bad at all. I'm going to leave you the third one to do for homework. Let's step it up a notch in terms of difficulty. Here we'll have multiple formula, and we're probably going to use one to help us find information in the other. Okay? So here we're talking about a surface area of a sphere. That's growing. We're asked how fast the volume of a sphere is growing when the radius of the sphere is 5 meters. Well, again, these are spheres. You don't need to know that the surface area of a sphere is 4 pi r squared, or that the volume of a sphere is 4/3 pi r cubed. So that's all I'm going to give you. You guys write down the rest of the information that's given to you and that you're trying to find, and go from there. At least start by writing down the information that's given to you and what you are trying to find. And then we will together go from there. R is 5, that's easy, right? But the surface area of the sphere is growing at a rate of 10. This should be squared meters because it's area. Change that to squared meters. That would be dSA over dt, or ds over dt. And the question is, how fast is the volume growing? dV dt is my question. This needs to be written down every time. What are you trying to find? What else is given to you? Then you don't have to worry about the problem. You just can use this information just like we did a problem, like we did for problems on our homework and on our quiz today. Okay? Now, I want to find dV dt. Let's just go ahead and take the derivative of v. And I get dV dt equals 4 pi r squared dr dt. And I plug in 5 for r, and I get 4 pi 5 squared dr dt. Well, here's the problem. I can't find dV dt if I don't know what dr dt is. Well, maybe we need to use the fact that I know my surface area and how it's changing, and that will help me find dr dt, which will then help me find dV dt. So I'm actually going to also take the derivative of this. Typically, every piece of information that you're given, you use. There will be some cases when they're just not necessary. Okay, well, I do have dSA over dt. This is 10. I do have r. This is 5. Well, now I can find dr dt. 10 over 40 pi, which is the same as 1 over 4 pi. Well, that goes there. And now I can solve for dV dt. .25 cubic meters per second. Okay? Not bad. A little extra bit of difficulty because it's not as simple as just plugging in your information. We have to kind of find information from one formula and use it to find the other. Let's look at the next one. Now, in this situation, you will not be given any formula. Okay? So you have to develop the correct formula and then derive it correctly, find what you're trying to look for, plug in the information correctly. There's no help given. All the other ones, there's help given. So this is a step up in difficulty. You need to use the correct formula to figure this out. So let's see if you can do that. Hopefully you remember that the area of a circle is pi r squared. What do I use that will help me use that dd dt equals 3? Anybody? Which equals what? Yes. Diameter of a circle is just twice my radius. Now I have my two formula. If you don't have them, you have them now. So let's go ahead and find the answer. Now that we have A equals pi r squared and D equals 2r. You need to be able to come up with those, though, in the future. You didn't come up with them now. We get 18 pi as our answer. Squared centimeters, because we're talking about area. A unit times a unit gives me squared units. Yes, Ms. Roth.
How did you get dv over dt to dr?
I took the derivative of this with respect to t. Does that make sense? Okay. I'm going to leave the next two to you guys to do for homework as well. So star those next two. That's part of your homework. Now, let's talk about why I told you to keep track of fixed things versus variable things. Because fixed things can be plugged into formula to make your equation easier to deal with, easier to derive, okay? Let's look at this situation. We have a cylindrical tank. It's losing water at a rate of 5 cubic centimeters per minute. How fast is the height of the water changing if the radius of the tank is 5 feet? Well, you would be given that the volume of a cylinder is pi r squared h. Now, a cylindrical tank is losing water at a rate of 5 cubic centimeters per minute. What is that? Volume, dv dt. It's losing water. Negative. Good. How fast is the height of the water changing? What is that we're trying to find? dh dt. And we are told the radius of the tank is 5 feet. Let's think about a cylindrical tank. Now, a cylindrical tank, its volume is always pi r squared h. Well, let's think about this cylindrical tank. If we know its radius is 5 up there, the radius is 5 everywhere. And yes, the volume of any cylinder is pi r squared h, but of this cylindrical tank, the radius will always be 5. This is a fixed quantity. Since it's fixed, instead of taking the derivative of this and having to use the product rule and take the derivative of pi r squared first times h plus the derivative of h times pi r squared, no, instead you can change your formula, because for this cylinder, the radius is always 5. If something is fixed, you can use that knowledge to simplify what we start out with. You can't plug it in if it's not fixed. If, like, you're talking about the height changing, you can't plug in the height of 2 or something. because it's like, well, no, it's not 2 always. We're talking about like the height of the water. Here, it's not really the height of the tank. It's really the radius of the water that we would say would be consistent. The water's radius would always be the same. Okay. So now that I have simplified this, I can take the derivative and I can find dH dt. Go ahead and do that. I would not ask you to change the units. We'd probably stick with centimeters. This is probably centimeters. And this would be a height, so it's units to the first power. Centimeters per minute. So that means the volume is decreasing, the height is decreasing. That makes sense. Okay. Now you're going to do this one for homework, and we're going to finish up with something like this. You'll see you'll have one like this out of your book. Homework is also out of the book. There's a couple problems out of the book. Okay. Pile of dirt is growing at a rate of 10 cubic feet per second. A conical pile, you need to write in conical. Conical pile of dirt. The radius of the pile is always 3 times the size of its the height of the pile. This is why I'm doing this one and not the other one, because it's messed up. The height of the pile is always 3 times the size of its radius. How quickly is the height of the pile changing when the height is 2 feet? Yeah, it doesn't make. The radius of the pile is always 3 times the size of its height. Thank you. Okay. How quickly is the height of the pile changing when the height is 2 feet? So the volume of a cone is 1/3 pi r squared h. This is not something you'd have to memorize, you'd be given. The question is, how quickly is the height of the pile changing? That's dH dt. H is 2. The dirt is growing at a rate of 10 cubic feet per second. Cubic, that's volume. We're told that the radius of the pile is always 3 times the size of its height. Now, here, you won't be given this in the future. I gave it to you now. You will have to be able to write that 3 times the height is your radius. What's important about that is that this is always true. This is a fixed relationship. Well, sure, for the volume of just some random cone, the volume is 1/3 pi r squared h. But for this specific cone, I can change some things. For this specific cone, instead of having r squared, I can have 3h squared. Now, this formula just has h's. Well, that's good because I want to find dH dt. I could have solved for h as 1/3 r, and if I wanted to find dr dt, I could have found that by plugging in h in terms of r. But instead, I can now simplify this formula. It's going to be a lot easier to work with. Take the derivative of it with respect to t, sub in my information to solve. H is 2. dHdt is what I'm trying to find. dVdt is 10. dHdt, I get 36 pi, 10 over 36 pi. And this would be the height, so it'd be units to the first power. Okay. Fixed relationships, fixed quantities, you can plug into your formula. Okay. The remainder of those problems due for homework as well as book problems. There are some book problems, so look at the worksheet, please. They will all have numerical answers. I'm going to do the book problems. This is a bonus. I'm going to do those remainder of those problems on my video. So if you want to watch the video to look at the answers to these problems, they'll be on the video. All right, let's go back and do the remainder of the problems. Here is another problem. Volume of the sphere is increasing at 3 pi cubic centimeters per minute. At what rate is its diameter increasing at the instant the radius of the sphere? Okay, so I want to find dt the moment when r is 3. This is a changing variable, and I'm told that dv dt is equal to 3 pi. Volume of a sphere would be given to you, 4/3 pi r cubed. I assume that we're going to use the diameter is equal to twice my radius. Let's take the derivative and go from there. dv dt is equal to 4 pi r squared dr dt. dv dt is 3 pi. R is 3. I can solve for dr dt. That's a good start. So the pi's will cancel. It'd be 3 over 36, which is 1 over 12. Well, dd dt is equal to 2 dr dt just by taking the derivative of this with respect to t. If dr dt is 1/12, dd dt would be 2/12 or 1/6. This would be in units to the first power. And we're good. Okay, next problem. At some point, the rate that the circumference of a circle is growing is 4 times the rate at which the area is growing. What is the length of the radius at that point? So this is interesting. We got the rate that the circumference is going. So I'll say that dc dt is 4 times the rate at which the area is going. So 4 dA dt. I'm trying to find r. Well, let's see what we can do. Area, you'd have to know is pi r squared. Circumference is 2 pi r. Let's just take the derivative of both of them and see what we can do. There's going to be a lot of different ways to do this. I'd get dA dt is equal to 2 pi r dr dt. Here I'd get dc dt is equal to 2 pi dr dt. Well, I know dc dt is 4 dA dt. So maybe instead of dc dt, I'll write it as 4 dA dt. And I get 2 pi dr dt. Well, I can solve for dA dt. I could even solve for dr dt. Let's solve for dA dt by dividing by 4. I get dA dt is equal to 1/2 pi dr dt. And I could plug that into my other formula. So I have 1/2 pi dr dt is equal to 2 pi r dr dt. Well, the dr dt's will cancel when I divide by that. The pi's will cancel. I have 2r equals 1/2, so r has got to equal 1/4, whatever the unit is. Okay, so again, you're using both formulas kind of to help each other out. We have one more problem. The rectangle's height is growing by 2 inches per second. The length is 4 inches. At what rate is the area of the rectangle changing? So I'm trying to find the ADT. I know that the HDT is equal to 2, and I know that the length is 4. Well, looks like my area formula is just going to be length and height, because I'm using L's and H's for me. And I don't care what you use. You can use X's and Y's. You can do B and H. But it's very important to understand that this rectangle's length is 4, and is always 4. This is fixed. Knowing that this is always true, I don't take the derivative of this. I actually take the derivative of that. It will be much easier to work with. You can do this problem by taking the derivative of this, but you'd find that you'd have to understand that some values are going to be negative, some values are going to some values are going to have to be 0, but they're not given to you as 0. You'd have to just understand that. So instead, we plug in fixed, we find the ADT, we plug in DHDT, and we get A, 8. Should be area, so squared units. Okay, that's it. Those are the remainder of the problems for the first lesson of related rates. Oh, there's one more. Side lengths of a square are shrinking, so we'll call that dsdt is -2. How fast is the area changing? dAdt equals what? Well, area of a square is just s squared. So watch. I get dAdt equals 2s ds dt. I'll need to know that that's -2. I'll probably have to also be given some more information when s is, let's just say 1. So 2 times -2 times 1, and I'd get dAdt equals -4. At the area, that's squared feet per second. Okay, so did not give you enough problem for that one or the other one that we did earlier, but that should be it. All right, thank you.